Bismillahirrahmanirrahim. Assalamu alaikum. Everyone, my name is Modulus and this is the lab part of Plain Reinforced Concrete 2 for batch 2017 section A, B and C. In this lab, we will learn how to find the elastic modulus of concrete. This is the sequence of my today presentation. I will start with the recap of the previous work, followed by the introduction of today's experiment. Then I will discuss the procedure and the calculation part, and then I will tell you what you guys have to do next. So first, let's have a quick recap what we have done previously. In first 7 weeks of spring semester 2020, you guys perform casting activity following ASTM C192, which is standard practice for making and curing concrete test specimens in the laboratory. So for making concrete, what you have to do? You have to add coarse aggregate, some of the mixing water, and the solution of admixture if you are using any admixture in concrete mixer, and start the mixer. Then you add the fine aggregate, cement and the remaining water and allow all the ingredient for mixing 3 minutes, followed by 3-minute rest time, and then you give final 2-minute mixing. So after mixing and making concrete, you have to place it. So ASTM C192 also guide you if you are placing concrete and the least dimension of your specimen is in the range of 75 to 100 mm. In that case, you have to cast it in 2 layers. If it is 150 mm or 6 inch, in that case you have to cast it in 3 layers. If it is 225 mm or 9 inch, in that case you have to cast it in 4 layers. So ASTM C192 also gave you some precautions that for making concrete, the ingredient temperature should be in the range of 20 to 30 Celsius degree. If the concrete slump is greater than 25 mm or 1 inch, in that case you can use compaction rod or a vibrator for compaction activity. But if the slump value is less than 25 mm, in that case you have to use the vibrator. Now we have two type of vibrator, external vibrator and internal vibrator. So ASTM C192 also guide you which type of vibrator you have to use. If the least dimension of your prism, cube or a cylinder is less than 100 mm, in that case you will use only external vibrator. But if the least dimension is greater than 100 mm, in that case it's your choice. Either you can use internal vibrator or external vibrator. Also C192 tell you that the concrete curing temperature should be 23 plus minus 2. So now coming toward the introduction part, the objective of our today experiment is to find the elastic modulus of concrete, and the test standard which we will use to perform this experiment is ASTM C469, which is standard test method for static modulus of elasticity of concrete in compression. The apparatus which we will be used is compression testing machine and compressor meter. This is compressor meter assembly. So we require at least 3 concrete cylinder and the height to dia ratio of those cylinder should be 2. So coming toward the procedure part, out of 3 cylinder, 2 should be crushed in compression according to ASTM C39 to find the ultimate strength of the concrete recipe. The remaining one cylinder will be used to find the elastic modulus. So now you have to set up the compressometer assembly around the remaining cylinder and place it in the compression testing machine. Now you have to apply the load in 3 cycles on that cylinder, but the maximum load should be 40% of the ultimate strength of that concrete, which you have to find by crushing in first step. So you have to record the load and deformation reading at fixed interval of load, but do not record any data during the first cycle of loading. Your calculation will be based on the average result of your subsequent loading cycle. To determine the actual deformation, you have to divide the dial gauge reading of compressometer by 2, and the strain will be obtained by dividing the actual deformation by gauge length of your compressometer. Then you have to plot the stress versus strain curve, which will be used to find the elastic modulus. So, moving toward the calculation part, you guys have to find different elastic modulus from the stress strain curve of concrete. The first one is the tangent elastic modulus. It is the slope of a line of a tangent which is drawn to the stress strain curve of the concrete at any point within 40% of ultimate stress. Then we have secant elastic modulus. It is the slope of a line drawn between origin and 40% of the stress of the failure load. Then we have chord modulus. It is given by the slope of a line drawn between a point representing longitudinal strain 50 micron to the point that corresponds to the 40% of the ultimate load. Then you have dynamic modulus. It is kind of tangent modulus. So the slope of the tangent which is drawn at the origin of stress strain curve give you dynamic modulus. So you have to tabulate your data in this form: load at a fixed interval, then the gauge deformation. From gauge deformation you have to find the actual deformation. You have to divide the gauge deformation by 2, you will get actual deformation. For strain, you have to divide the actual deformation by gauge length to get the strain, and for the stress at each point, you have to divide the load by area of the cylinder. So at the end, you will get a stress strain curve like this, and then plot and then calculate different elastic modulus from that stress strain curve. Okay, now what you guys have to do next? You have to watch the second part of this presentation, which is the laboratory demonstration of the elastic modulus of concrete. Then you have to carry out the calculation on the data which is provided to you guys in Excel file to calculate different elastic modulus. At the end, you have to compare experimentally determine elastic modulus with ECI empirical formula result. That's all from my side. Thank you so much. Allah Hafiz.